There's more to surfaces than meets the eye. Science is constantly coming up with new ways of creating functionalized textures. These micro or even nanostructured surfaces endow materials with innovative properties. The classic way to produce such surfaces, especially over large areas, is with wet etching technology, a complex and environmentally hazardous method. But there's a better alternative: laser technology.
A laser machine is a relatively compact, simple piece of equipment. What's more, it has a lower environmental impact and uses less energy. In other words, it brings both technological and economic benefits.
Whole sectors of industry have been looking for a process suitable for major components. And now a joint project team, led by the Fraunhofer Institute for Laser Technology, ILT, has come up with an alternative: a high-performance, ultra-short pulse laser to create micro and nanostructured surface textures.
Typically, USP lasers operate within a pulse range of 100 femtoseconds to 10 picoseconds.
1 femtosecond equals 10 to the power of minus 15 seconds.
The interaction time is very short. This means that surface material is ablated without any significant generation of heat. In effect, the use of ultra-short pulses means that the material barely registers that energy is being applied. The aim of the project was to boost productivity. A big challenge was to handle the increased high average power of the laser system and thereby scale up throughput, but without having to compromise in terms of precision.
The research team's ultimate goal: to create a new multi-beam process suitable for generating textured surfaces on large components.
What sets the optical system apart is that it incorporates a high-performance beam splitter. This splits a single laser beam into individual beamlets with an overall loss in efficiency of less than 2%. We've created 8 beamlets, each of which can be individually controlled like a dot matrix printer. That makes it possible to produce a whole range of surface textures.
It's the fruit of close cooperation between a joint project team that was able to cover the entire development process. For the first time, it is now possible to economically process a surface area of several square meters rather than just a few square centimeters.
A key aspect of the project was creating a digital workflow. This starts with the digitalization of microstructures, which can then be recreated over an area of several square meters. That means on a cylinder 3 meters long and 1 meter in circumference. For me, the use of USP laser represents the future of material processing. It is a wear-free and flexible digital tool that never goes blunt. It is always sharp.
A paradigm shift in precision technology. It saves resources and has enormous potential for a wide variety of applications, whether making filters for microplastics, improving the efficiency of major components, or creating structures that are resistant to bacteria. In the future, this new technology will do more than just scratch the surface.